Hello, I'm Susabhan Sengupta and I'm going to solve question number 3 of NSEM. So we have been given this question where we have to climb a wall. We have been given that we are climbing a wall of given a function f of x, which is 1000 minus 0.005 x square minus 0.01 y square from a point 60, 40, 99966. And here we have also been given that we have to take north as positive y-axis and the east side as positive x-axis. So we have to from in the first part we have to find if we walk down south, then what will happen, it will ascend or descend, and at what rate. So to find out that, we need to find directional derivative of the function f of x, which is this. So and we know that directional derivative formula is gradient of x into the unit vector. So here first, for the first part, we have been given, if this is, if in this north is positive, so south will automatically become negative, and in minus j cap direction. So unit vector is equal to u upon mod of u. So direction of u, we know that from the here it is minus of j, and mod of u is 1, we know that. So unit vector or u cap equal unit vector or u comes out to be minus of j cap upon 1, which is equal to minus of j cap. Now we have to find the gradient. We know that the gradient for the gradient formula is del f del by del x I cap plus del f by del y j cap. So we have to find the partial derivative of the of this function. So it comes out to be minus if we with respect to x, the function will come out to be minus 0.01 x I cap plus 0.02 j cap. I think it's negative. If you see, yeah, it will come out to be negative, and here it will be 1 y also. Y, let's cross it and rewrite it again. Minus of 0.01 x I cap plus minus of 0.02 y of j cap. So here, now we have been given this equation. Now let's put the values of the point, which is this 60 and 40, and find out what, and satisfy this question. We will get by putting values x comma y, we get minus 0.6 I cap plus minus of 0.8 j cap. So now we have find the now we got this and this. Now we have just to multiply. It's not a cross multiply, it's a dot. It's a dot product, not the cross product. So if we take out the dot product, du direction derivative of function del f u into unit vector, we will get minus 0.6 into 0 plus minus of 0.8 into minus of 1. This part comes out to be 0 and this will come out to be 0.8, which is greater than 0. So now as it is greater than 0, so we can here conclude that we will ascend at the rate of 0.8 vertical meter square. Full stop. Now we have been given the second part where we have to travel in the northwest direction and found out that will we ascend or descend. So now we have to break it into components. So u cap, let's it be u, not the mod, just u. It will come out to be minus u cos 45 degree I cap plus u sin 45 degree j cap, which is equals to minus of, let's take u common from both and we get minus of 1 by root 2 I cap plus 1 by root 2 j cap. So this will be the unit vector. Now we have to find out the derivative, the gradient, which was 0.6 I cap plus 0.8 j cap in the negative minus. So now we have to cross multiply these two, dot multiply these two. So we will get here duf equal to del f into unit vector. We will get minus 0.6 upon minus root 2 plus of minus 0.8 upon root 2 I cap j cap. And after solving this part becomes positive and this will be negative. So after solving that, we will get here the final value comes out to be 0.8 positive, it will come out to be minus 0.2 upon root 2, which equals to minus 0.14. And as this value is negative, so it will descend at the rate of minus 0.14. Now for the third part, we have to find the largest slope. So we know that slope is largest in the direction of gradient, and we also know this 0.6 I cap plus 0.8 j cap. Now from this statement we can write here this equal to this gradient, unit vector into is equals to gradient, the unit vector of gradient, which is equal to 0.6 I cap plus 0.8 j cap upon under root of 0.36 plus 0.64, and this value is equal to 1, so which is 0.6 I cap plus 0.8 j cap. And now if we find the directional derivative and find the dot product of these two things, we get 0 point del f into u. We get here 0.6 into 0.6 plus of 0.8 into 0 into 0.8, which is equals to 1. So directional derivative is equals to 1, which is greater than 0. So we can write here that it will ascend, and here and this part, this was negative, so it will descend at rate of 0.6, which is the answer, at rate 0.14, and here ascend at rate of 1. And now we have to find the direction at which theta we have to find. Now to find theta at which it will ascend, we can do theta is equals to tan inverse of the slope of directional derivative, which was 1 here. So theta is equals to tan inverse of 1, hence 45 degree. So now this is the answer. At this theta, it will ascend at the rate of 1. Thank you.